Okay, class, picking up where we left off at, we're on part D, and it says which model will make the best prediction past t is equal to 22. So what you would do is you would have to put this in your calculator, and if you notice here that this model here, it will curve, but it will lower, it will lower slowly and flatten out, but it will never go back, nor it will be negative. So the best model would be exponential. But here, if you do t is equal to 22, the linear would be bad because it'll go negative, and the quadratic would be bad because it will go back up. So that's why it should be exponential. Okay, now we need to scroll on to the next page where we have to fill in the table below. Now I took the liberty of filling this out so that we could smoothly go through this. Okay, we have our data set. It's a percent of adults in Michigan with diabetes. And of course, we're assuming we're starting from 1990. So we will put these values in. This will be our L1 and the percent will be our L2. And then if you look here at the scattergram, you notice it's more of a linear model. And so it'll be linear because the points aren't curving. They're basically going almost straight. So we will put this into our calculator and get our linear regression, and we also will get our R squared, which will give us 0.992, and that is very, very close to 1. Now we come here to the second graph. If you notice here, again, here we're going to assume that we're starting from the year 1980, even though it started from 1985. So this is how we get our T, which is our L1, and the number of Home Depot stores is our L2. Now, when we put in this graph, you notice it gives us more of a curved line here. It doesn't cross the x-axis to go to negative, so this is more exponential because it's a form of classic exponential arch. Must be difficult for future predictions because it's really steep. And then we have y is equal to 24.4 times 1.198 to the t power. We know we will put that in our calculator, and our r squared is 0.9857. So we know that this is accurate. It's the best graph because it's very, very close to 1. Now, for the final graph, when you put this in the calculator, starting, again, we're going to assume that we start from 1980, and this is the U.S. AIDS rate. And if you notice here, our L1 would be these values, our L2 would be these values. Then we put this in here, it almost mirrors a parabola, because I could even draw a little line here, and it'll almost hit most of these points here, doing it as a parabola. Okay, so it's quadratic because it goes up and back down. So we could put these values in our calculator and get the quadratic regression, which we will have here. And our R squared will be 0.834, which is still very close to 1. Now, we have our warnings. Now, as you see, my page is a little off, but your next page will be the warnings, the data sets, and the scattergram best model. Now we come down here. Now, what we could do here is basically you could read this at your leisure. The only thing I need to add here is to look at both the scattergram and the R squared. Now that's one thing that I will always tell you for each one of these. You should look at both the scattergram and also your R squared. And basically you could read this at your leisure and we're done. It says note here. It says there are just a few other issues that can arise with fitting models. There are also many other possible models that are not covered in this course, but are in the calculator and Excel. That's just a little note for you, and we're done.